application, described in Ref. Boundary conditions were updated for most of the applications. On the ocean side, the estuarine models were nested to the Portuguese Coast Operational Modeling System, hereafter referred as PCOMS, following the downscaling methodology described in Ref. On the landward side, Douro, Guadiana, Mondego and Tagus estuaries were forced by river flow data obtained from the closest stable monitoring station from the Portuguese River Hydrometric Observation Network, http://sna.pt, Table 1. Due to the limited data available for the rivers discharging in the Aveiro, Lima, Minho and Sado estuaries, flow data were obtained from a watershed model for West Iberia with 2 km horizontal resolution, WI MOHID Land, described in Ref. Monthly climatology river flow or constant values were only used for other minor sources of fresh water, the Pranto River for the Mondego estuary, 4 for the Aveiro estuary and 2 rivers and 14 urban wastewater treatment plants, UOPs, for the Tagus estuary. As monitoring stations providing reliable and regular water properties were absent for many of the rivers, water temperature in all the estuarine applications was obtained from the WI MOHID Land model application and river salinity was considered as pure fresh water. All the estuarine models were implemented in 2D depth integrated domains except for the Tagus application, hereafter referred as Tagus Mouth, which is a fully 3D baroclinic hydrodynamic and ecological application. The Tagus Mouth vertical discretization consists of a mixed vertical geometry which is composed of a sigma domain with 7 layers from the surface until 8.68 meters depth, with variable thickness decreasing up to 1 meter at the surface, on top of a Cartesian domain of 43 layers with thickness increasing towards the bottom. Each estuarine application was forced with a higher horizontal resolution meteorological model available for its domain. Meteorological model applications provided 3D fields that included relevant model forcing variables, i.e. precipitation, solar radiation, wind modulus and direction, relative humidity, air temperature, etc., and whose surface layer is interpolated for each modeling domain by triangulation. The Minho, Lima and Douro estuaries were forced using WRF model results with 4 km horizontal resolution generated by Media Galicia, MG, http://www.mediagalicia.s. The Tagus Mouth model application is forced using 3 km horizontal resolution WRF model results provided by the ISD Meteorological Group, ISD, http://mateo.tecnico.lisboa.pt. The Aveiro, Guadiana, Mondego and Sado modeling domains used, as atmospheric boundary conditions, MM5 modeling results with a horizontal resolution of 9 km provided also by the ISD Meteorological Group. This set of numerical models was integrated and synchronized through the ART software, Automatic Running Tool, a software for the automation of model simulations developed at ISD that is currently used by many operational applications. The ART tool is a standalone application, independent, compiled, and able to run in any Windows operative system. This tool can be seen as the heart of an operational framework, controlling the execution of other auxiliary standalone applications or even scripts, for example conversion of file formats, interpolation and specific downloading procedures, adapting automatically the configuration files and launching those applications. The ART tool preprocesses the boundary conditions from different sources needed to run the model, and executes the MOHID Water and Land model applications using the configured files. After each estuarine model has concluded, it executes the River Out software, a software designed specifically to extract and calculate the water fluxes and concentrations for all the cells comprised at a fixed longitude and between 2 defined latitudes and to store them in an organized manner. General scheme of the Automatic Running Tool, ART, depicting the preprocessing, modeling and post-processing cycle of operations with the elements used for the MOHID Land and MOHID Water applications used in this work. The River Out software is executed during the post-processing operations of the estuarine model application. Table 1 summarizes the main characteristics of the estuarine model applications including the modeling domains, their location of their mouth where the fluxes were calculated, the source of fresh water forcing and the reference of the previous study. Most of the numerical models here described are currently running operationally in the Mertec Research Center, http://forecast.mertec.org.